Okay, all right. So here's what we're gonna do today, and the bell just rang. Okay, how about that? All right. So here's what we're gonna do today. Today we're going to look into specifically into arithmetic sequences. Okay, we're gonna spend a couple of days on that. Actually, more than a couple of days. And yeah, that's it. Okay, all right. So let's see what it looks like. Okay, all right. So here's what I'm gonna do today. All right. So we're gonna hit the ground running, and I want to show you the toughest part of this unit first. Okay, and then once you start doing some of the problems, you realize actually just how straightforward this is. Okay, so now based on yesterday's lesson, right? We talked about arithmetic sequences and geometric sequences, right? So today we're gonna focus on arithmetic sequence, meaning what happens if we're just adding one consistent number from one term to another? Okay, so what we're gonna do is consider number one, right? Looking at this. Now, first of all, what type of sequence is this? Yeah, it's arithmetic, right? Because every term you just have to add 4 to the previous term, right? So one of the things I want to get you to see is that the actual formula as it will be provided, all right, on the regions is something that looks like this, all right, as it pertains to arithmetic sequences but not geometric sequences. Okay, so this is provided on the regions. Now, what is this exactly, right? What's this crazy looking thing? This is called the explicit formula. All right, oh, it's right here. This is called the explicit formula for a arithmetic sequence. Okay, so there are 4 categories. Okay, let me show you what those are first. All right, but I will not show you the formulas because I don't want to scare you off just yet. So, by the way, so on the regions, all right, let me show you this. Uh-oh, what happened? On the regions, you will see this, okay? These 2 formulas given to you, okay? Now, what that also means is that there's a second type of formula that they didn't give you, and we need to spend a little bit more time on that later. Okay, so now, this is the summary. So this is actually a graphic organizer I made. All right, so there are a couple of things going on here, right? Right off the bat, we already spoke about arithmetic sequences, right? What those are and what geometric sequences are in the previous lesson. All right, so, and there are also 2 types of formulas. One is called an explicit formula, and what an explicit formula allows you to do is to go, so I'll give you an example. Let's say we have several numbers here, right? Let's say like 2, 4, 6, 8, 10. Straightforward, simple, right? What an explicit formula allows you to do is it allows you to ask the following question. Knowing that this is the first term, right? And this is the second term, and that's the third term, so on and so forth. Can you tell me what the hundredth, no, not the hundredths, hundredth, what's the hundredth number in this sequence, right? So instead of adding it over and over, add 2, right, like so on and so forth, you can just use a formula to find out what exactly is the 100th term. Now, I know what some of you are saying. You can say, well, I'd rather add 2, but sometimes the number isn't 2, right? It's not that low. It's not that simple. So that's what an explicit formula does. What a recursive formula does, on the other hand, all right, is it allows you to find the nth term of a sequence, but it uses the previous terms. It uses a and then the previous term, right? A of, n minus 1. And as you can see, maybe I shouldn't do this. Shouldn't try to scare you like that, all right? You see this notation, right? A and then n minus 1. So it is for the geometric. Okay, so it's a very, how would I say? It's a slightly more roundabout way to look for a specific term in a sequence, okay? And explicit applies to arithmetic and geometric and recursive also. So there are 4 things we have to go over in this unit, all right? So arithmetic, explicit, which is what we're doing today, all right? Geometric, explicit, which is what we're gonna do in a couple of days. And then afterwards, we're gonna do arithmetic, recursive, and then geometric recursive, because recursive tends to be a little bit more difficult to remember. because it doesn't go straight to that term. It doesn't head straight to that term, all right? It's a very roundabout way to look for a number, okay? And so that's what I want to get through to you right now before we even embark on this unit, okay? Just so that we know what we're looking for. So let's go back to this then, right? Okay, so let's go back to this. All right, so here again, right, let's come back. We're looking for an explicit formula to an arithmetic sequence. Meaning, can I give you a formula, an equation, where no matter what term I'm looking for, so let's say we got this going on, right? So let's say we got this going on. Oh wait, the next term is not 20, it's actually 22. All right, so on and so forth. Could you tell me, if I were to ask you, what's the 102nd term of this sequence? Is there a formula that you can tell me where I could just put 102 in there somewhere and find that particular number? Yes, there is. What is that formula? That's this one, the explicit formula. Okay, now let me clear out some space first. Okay, all right, now knowing that, I thought about this really long because I actually, when I was in high school, again, I never, like, my teachers never taught me this, like, you know, so it took me a while to try to get a hold of this concept. Okay, now, so when I looked at this formula, I was a little concerned also. All right, because I look at this and I say, wait, like, wow, there's a lot of things going on. Turns out it actually isn't. Okay, so now, one of the ways that I think we're gonna do this is by using something we've learned before, and that is the slope-intercept formula. Okay, so let's try this. Okay, so instead of just memorizing this, I'm gonna teach you how to make it first, and then hopefully they'll make some sense. All right, now, looking at this, right, so let's say, right, back in the day, we have x, y, we list our table of values here, so on and so forth, right? So imagine, right, so the first, by the way, also, one of the things I want to get you to understand is, here, in this case, for x, it's the number of the term. All right, and the number of the term, we're using the letter n to represent. So this is not technically x in our lingo, all right? It should be n, okay? Now, what does n stand for? It's the number of the term. So like, for example, first term, right? Look at this table here. First term, right? Second term, third term, fourth term, fifth term, so on and so forth, okay? Now, what's the first term? What's the first number in this sequence? It's 2, right? So this is, yep. And so this is the actual number, right? N is the term itself. A of n is the actual number of the term, right? The nth term, your answer. See that, right? So what's the second term? 6, right? So look, I can actually plot this, okay? Watch this. First term is 2. First term is 2. Second term is 6. And then third term is 10. All right, I'm out of space already, right? And then I got my 3 points here. Fourth term is 14, right? And fifth term is 18. So far, so good, right? I'm just recording what I see here. Now, I don't know if you've noticed, right? This forms a straight line. You see that? Right? So, that said, we can say that this is a straight line, so we can use the tool of the slope-intercept form to find the equation here. Okay, now the only thing I gotta say is you're not really supposed to connect the 3 points because these terms, they're what we call discrete, meaning they're separate, meaning they are not continuous. So you know how a graph is supposed to suggest that every point on the line, right, have the same slope, for example, right? But here, we can't really connect them because that wouldn't be true. It's not true that every point on this line is gonna fit into this equation. So therefore, we use the word discrete, meaning they're separated. These numbers are on their own. They're not part of a continuous line, so they're not continuous, okay? But however, we can still apply the concepts of this. Now, remember how we have to find, right? Remember, so for example, by the way, so this is like 1 comma 2, 2 comma 6, right? So remember how we used to find the equation of the line, right? Slope-intercept form. So for example, I need to find the slope first, right? So this should be a review. Slope, so delta y over delta x. So 6 minus 2, 2 minus 1, hold on. So now, what's the slope then, right? 6 minus 2 is 4, 2 minus 1 is 1, so the slope is 4. Now, once we find the slope, what do? Yeah, we pick a point, right, and then we plug it back in. So here, y equals to mx plus b. So y is equal to 4x plus b, right? And then let's use 2 for y. So here, I'm looking at this number here. 2 is equal to 4 times 1 plus b. So 2 is equal to 4 plus b, so b is negative 2. So our equation, right, in the old days would be y equals to m, which was the slope. M is 4x minus 2. Now, how does that relate to this, right? I mean, that's the big question, no? So, okay, now, first of all, if you look at these two equations, they're actually the same equations. Look, why? Because if I got y, right, which is my answer, so to speak, right? Again, I'm comparing these two equations. You see how this is negative 2? That's the first term. Okay, right? So that's negative 2 here. This standalone term is this guy right here, right? And then plus, now, here I got 4x, and here I got 4 times d, right? So if I place 4 here, and I place d here, right? Doesn't that mean I got the equation already? Right? So, now, actually that's not true. Okay, hold on. Edit. So, okay. So what we have here, right, is the negative 2 is the first term, right? And then we have x, it's actually x times 4, right? Because that's what 4x is. X is this here, and the common difference is 4, right? Isn't the common difference 4, right? 2 plus 4 is 6, 6 plus 4. So the slope, in other words, this slope here is the common difference, all right? Now, I know I'm not doing the best job here, all right, because I'm still having a very hard time trying to, not that I have a hard time connecting these two, but that I'm trying to find the best way to explain these ideas to you, okay? So, and that's what we have, right? So, having said that, let's try this one then. Wait, how am I doing on time? It's all right. Okay, so what about this, right? So if you want to, press pause right now, try this on your own. If not, then I'm just gonna go ahead and do it. So press pause right now. Okay, let's go over this one then, right? So again, I'm gonna try to set up a table, right? X, Y, right? The first term is 22, second term is 28, the third number, so first, second, third, fourth, right, so on and so forth. So the third number is 34, the fourth number is 40, right? Okay, now, having said that, what is let's find the slope-intercept form first, okay? And that's the best way to attack these questions, okay? So again, remember, right, what are we trying to do? If I give you a sequence of 4 numbers, an arithmetic sequence of 4 numbers, what do? Right, that's the question. So, okay, now, here I got this, so let's find the slope first. So let's see, I got 2.0122 and 228. So that's, let's see, slope is delta y over delta x. So that's 28 minus 22. Pardon the handwriting, I'm trying to get this done before the day starts. 6, so the slope is 6. So I know that the common difference now is 6, okay? That's good, that's important, all right? That's progress, okay? And now what I'm gonna do is I'm gonna rewrite this, because what I wanna do is get the y-intercept. In other words, I wanna know what the first term is. That's really what I'm doing, Okay, I'm looking for this y-intercept, right? So let me help you out here. B stands for the first term. I want to know what the very first term is. Okay, so now let's see. Hold on, I gotta check something real quick. Okay, all right. So now, again, let's keep going, all right? So I don't know what I wrote here earlier. So let's do that. Okay, so I'm gonna use this one, okay? So let's see. 22 is equal to slope, which is 6 times x, which is 1 plus b. So 22 is 6 plus b, so b is 16, right? There's our first term, actually. Okay, so now, that said, what's the equation then, right? Y is equal to 6x plus 16. Now, let's go back to our original formula. Okay, so let me see if I can just copy this, actually. Hold on. Nope, I copied the highlight part instead. Okay, all right. Let me put this down here. Right here. Okay, so now let's compare and contrast then. All right, so here we got our formula. Right, okay, so look, first term is 16. Right, so our first term is 16. The common difference, right, is the slope. So the common difference, right, is 6, right? And that's it, okay? So that's all you need to know about this. All right, that's it. So let's summarize real quick. So today what I attempted to do is this, okay? Hopefully I did a halfway decent job, is to show you, hey, if we got, specifically speaking, an arithmetic sequence, and I give you a series of several numbers, and I ask you, hey, can you give me a formula to summarize this sequence? And the answer would be yes, right here. This is the formula, but we have to re-look at the formula in a different way that looks more like this, so that therefore we knew to have the following information. Slope stands for the common difference. All right, again, the computer is really slow. The slope stands for the common difference, and the first term is represented by the y-intercept, which makes sense, right? Because look, the original point was really like down here, right? Because it was, if you were to try to connect this line, the y-intercept would be at -2 anyways. Okay, so, all right, yeah, let's stop it today, okay? And yeah, that's it. All right, thanks for watching, and tomorrow we'll continue. Okay, have a good day. Bye-bye.
OMG, that was so good.